4.4, solving factor, solve by factor, but now we have ax squared plus bx plus c, which makes this a little bit difficult. Started using some different methods last semester I thought was helpful. So how to factor these, what I would do is, I would, first step is to multiply a times c, in this case 5 times 6. So 5 times 6 is 30. You can write that a times c right there, or ac. We want factors of ac to have to b, which is negative 17. So what two numbers multiply to get 30 to add to negative 17? Well, that would be negative 15 and negative 2. Negative 15 times negative 2 is 30. Negative 15 plus negative 2 is negative 17. Now, what we can do as a shortcut is take our a, whatever our a is, in this case it's 5, and divide each of those constants right here. So if we can divide it, what we're going to do is reduce it. So negative 15 over 5 reduces down to negative 3, because 5 goes into 15 3 times over 1. Okay, we're going to slap an x with it, and that's going to become x minus 3. Okay, 1x minus 3. So basically, this part goes first, and this part goes second. Okay. The other one we can't reduce. We can't reduce negative 2 over 5. So we're going to leave that as 5x minus 2. Okay? And you can see this part goes here, and this part goes here. But in the end, that's our answer, x minus 3 parentheses 5x minus 2. I think that's the quickest way to factor. If you have another method you've done before that you like better, you can do that. But I think this is the best way to do it, the quickest way to do it. That'll give you the best chance to have success in factoring when you have an A out in front. So you got to make sure you take into account, does it have an A in front or not? And this is the way to do it if it has an A in front. Okay, same thing here. 3 times negative 7 is negative 21. And B is 20. So what factors of negative 21 that add up to 20? Well, that would be 21 and factors of negative 21. Yeah, 21 and negative 1. 21 times negative 1 is negative 21. 21 minus 1 is 20. That works. So now we're going to take our A, which in this case is 3. We're going to divide each of those by 3. If we can reduce it, we want to. So this reduces. 21 divided by 3 is 7 over 1. Okay, so that'd be, we slap an x there, so it'd be 1x plus 7. Okay, this one can't reduce, so we just put an x with it on the bottom. So it'd be 3x minus 1 on the bottom, and that would be it. You can always check these too. If you want to check and make sure they work, x times 3x is 3x squared, x times negative 1 is negative 1x, 7 times 3x is 21x, 7 times negative 1 is negative 7. So you get 3x squared plus 20x minus 7. And that would be your answer. So you can always check your work, but this method always works as long as you do it correctly, as long as you do steps. And I'll write the steps on the board when we get to class too. So practice these on your own using those steps to see how far you can get, see how well you can do. We'll keep practicing in class. All right. Factor special products, the same rules that we had in the other day. If they're a perfect square trinomial or a difference of squares binomial, then you can use those rules to do it. So 9x squared minus 64, there's 2 of them, so are they perfect squares? Yes, they are both perfect squares. So what we want to do is take the square roots of them and add and subtract them. So we'd have 3x plus, what square is 64? 8, and 3x minus 8, and that would be your answer. And that's how you factor A. Okay. B is a perfect square trinomial. So again, this is a lot easier if you can recognize that that's a perfect square and that's a perfect square. The square root of 4y squared would be 2y. And the square root of 25 is 5, so it'll be 2y plus 5 squared. And that's all you have to do. That's quick and easy as long as you can recognize that those are both the perfect squares. Otherwise, if you try and use the AC method on B, that takes a long time when you start multiplying 4 and 25. So this is the easiest way to do that. On C, again, 36 is a perfect square. 1 is a perfect square, so we can do this. Square root of 36w squared is 6w. Square root of 1 is 1. So, but since there's a minus in the middle, notice that minus sign right there. You got to do 6w minus 1 squared, and that would be your answer. So if you can learn those special factoring patterns that we learned the other day and use those correctly, it makes these a lot quicker. If you have to try and use the AC method for B and C, it's going to be a lot more difficult. And whenever you see two binomial, always think difference of two squares. Take the square roots of each of them, add them, and subtract. Again, you can practice some of these on your own. These are all perfect square or difference of two squares, so you can get that practice on how to figure out how to write those. All right, factor out monomial. When factoring an expression, first check to see whether the terms have a common monomial factor. So you always want to do that first. Be sure to factor out common monomial from all terms expressed, not just the first term. So that's something that can mess you up. So the first one, we got 5x squared minus 45. Well, they both have a common factor of 5, so we can take out a 5, leave that as x squared, and then we also have to divide 45 by 5, which is 9. Well, x squared minus 9 is the difference of two squares. They both are perfect squares. So then we can factor those by writing 5 parentheses x plus 3 parentheses x minus 3, and we're done. So that's how you would completely factor A. B, they both have a common factor of 2. Every 6, 8, 14, all a common factor of 2. So we're going to factor out a 2. And when we factor out 2, we end up with 3q squared minus 7q plus 4. Because we divided each of those factors by 2. Now we can use the AC method. We can multiply 3 times 4, which is 12. Factors 12 that to negative 7, or negative 4 and negative 3. But whenever we have an A, we got to divide by our A term, or leading coefficient, which is 3. So we're going to divide this by 3 and divide this by 3. Well, negative 4 over 3 doesn't simplify, so that would just be 3x minus 4. But negative 3 over 3 reduces down to negative 1 over 1. So it'll be 1x minus 1. We still have to bring down our 2, though. Whatever we factored out, we got to bring that 2 down. And that will be our complete answer. So 2 times parentheses 3x minus 4 parentheses x minus 1 is how you go about doing that. Let's look at C. I'm going to erase A just because I ran out of room, and you should have it down by now. Okay, so C, they both have a common factor of 5 and Z. Now, if the leading term is negative, you want to make sure you factor out a negative as well. So negative 5z is what you want to factor out. When you factor out a negative 5z, 5z squared divided by negative 5z is just z. And 20z divided by negative 5z is negative 4. Now, z and 4, z minus 4, you can't factor any further, so you're done right after that. You can stop. Okay. And the last one, D, I'm going to erase B because, again, I ran out of room. If you run out of room, just make sure you use substitute paper. So 12, 21, and 3 all common factor of 3. So I'm going to take out a 3 and be left with 4p squared minus divided by 3, 21, 7p divided by 3, that's 1. Okay? 4p squared minus 7p plus 1. So are there any factors of 4 to add up to negative 7? I don't think there is. I really don't think there is. So 4 and 1, 2 and 2, no way you're going to make 7. So at that point, you're done. And that's why you have to make sure, sometimes you rule like this is the perfect square, this is the perfect square, but that is not a perfect square triangle. You can tell because this number doesn't really fit with those other two. And that's something you'll have to pick up as you go along and try. But that's as far as you go. If all you can do is factor out a monomial, you can stop right there. All right, so make sure you factor out the common monomial on these ones, and then see if you can factor further either by using the AC method or using difference of two squares or perfect square trinomial to simplify it all again. Okay, so you can solve quadratic equations using this method. Pretty much the same thing, just factor and set both parts equal to 0. So this one we got 3 times negative 8 is negative 24 over 10. So what multiplies to get negative 24 and adds up to get 10? Well, that would be 12 and negative 2. 12 times negative 2 is negative 24. 12 plus negative 2 is 10. So we have a 3 in front, so we got to divide each of those by 3. So we'd have 4 over 1, x, and we'd have negative 2 over 3, x. So when it factors down, we'd have x plus 4 and 3x minus 2 equals 0. So that's how you would factor that one down. And then you set both parts equal 0. X plus 4 is equals 0. Subtract 4, x equals negative 4. 3x minus 2 equals 0. Add 2, 3x equals 2. Divide by 3, x equals 2/3. And those would be your two answers. The x plus 4 is probably really easy to say, that's negative 4 right away. But the 3x minus 2, you might not see that's 2/3 right away. So you want to get a habit of setting equals 0 and solving it until you can kind of see interpret that part as always being, well, you just add the 2 and divide by whatever's on the x. On b, you have to set equal to 0 first. So let me rewrite this. So 5p squared minus 16p plus 15 equals 4p minus 5. So you got to set equals. You want to set equals 0. So I would subtract 4p and add 5. So we get 5p squared minus 20p plus 20 equals 0. From there, they all have a common factor of 5. So we're going to take out a 5. So we're left with p squared minus 4p plus 4 equals 0. Now, there's a couple ways you can do this one, because I'm pretty sure this is a perfect square trinomial. Or you could just use the AC method and factor. Either way works. I'm just going to do the x method. Factors 4 with negative 4 will be negative 2 and negative 2. Whenever those two are the same, that's a perfect square trinomial. So we can write it as p minus 2, or we can write it as p minus 2 squared equals 0. Either way works. So you're only going to have one answer on this. You just set p minus 2 equals 0. Add 2. So p equals 2 is your answer. So that's how you go about solving that. I think since it's getting to 15 minutes, we're going to do example 6 and example 7 in class together and talk about those together, just because those will take a little bit longer to do. So we'll do example 6, example 7, and the guided practice of the class. That is homework. If you have any questions, make sure you ask in class or before class, and that is it.